So, is it possible then to think about a big change that must have occurred during human evolution? Because as we transitioned from hunting and gathering to being agriculturalists about 12,000 years ago, about the time we become more sedentary, about the time that wolves started to approach us and scavenge off the refuse we were producing, and we start our relationship with dogs, we see a change where there's a reduction in cranial capacity that is seen throughout all different domesticated animals. And also we see some really important behavioral changes that would allow for a level of cooperation, a level of tolerance that you wouldn't see, that we don't see any other time, and that, you know, allow for agriculture to essentially happen. People had to become incredibly tolerant of one another to allow the sedentary lifestyle and the high density living that is produced as a result of agriculture. So is it that we can see, if it's true, that there's a biological basis for this? Could we see any evidence for domestication in our own species in a similar way that we've seen in other species? Is there evidence for convergent evolution? Well, together with colleagues at Duke, Bob Seri and Steve Churchill and Kinji Tan, we conducted a study where we looked at humans who were still living as hunter-gatherers before this transition to agriculture, and then we looked at humans afterwards. And we looked at the facial features of those humans to look at how basically masculinized faces were. And we also looked at the brow ridge. That's this area above your eyes where you can see dense bone, particularly in the photo here, where the brow is actually quite big. And we measured the brows and we measured the facial features of people who were hunter-gatherers before agriculture, and then we measured people who were hunter-gatherers during this transitional period, and then people who were fully agriculturalists. And the prediction is that if people have been selected to be more tolerant, that to allow for agriculture, there really was an advantage to being essentially more peaceful, being interested in interacting and living in these high density situations, that you should see a change in the morphology of people before history that would reflect this selection or this advantage of being more friendly. And the reason we got interested in looking at the faces and the facial features, of course, is because that's where we see a big change, not only in foxes, but in other animals as well. And since we see this reduction in cranial capacity, we couldn't help but go look and see if we saw evidence in humans. And the reason, the physiological reason we thought this might be interesting is we know that during puberty, the brow ridge and the facial features in humans is a secondary feature of puberty, and is the level of testosterone your body is producing, or at least the level of testosterone your body reacts to, is related to these facial features or secondary sexual traits that result during puberty. So this on the left is a human who was still living as a hunter-gatherer in a period where people were still living at low density. And of course on the right is a more modern skull, and you'll see that, you know, there was a reason that we went and measured the brow ridges and the faces, because you can just see with these two examples where there's a really big brow ridge from humans living before agriculture and those living after. And here's the data, and essentially what we found was exactly what we had thought we might, which was the earlier humans had much more feminization in their brow ridge, and they had a much more masculine face, and that's represented by the skull in that top left corner. And then when you get to recent humans, recent agriculturalists, and more recent foragers, then you see these more feminized traits where the brow ridge goes away. For sure, that's where you see the big effect, and even you see changes in these facial features. So this suggested to us that partly what may have happened during human evolution is when you had selection for tolerance, for interest in others, you had a shift in these secondary sexual traits in the facial features as a result of changes in circulating testosterone, or maybe testosterone reactivity. And this is consistent with the idea that as we became more tolerant and more interested in each other socially, there was a change that is similar to what you have seen in other species that have been self-domesticated. So natural selection has affected us in a way that is analogous to what we've seen in the foxes and dogs and now even bonobos. So to summarize, work with great apes has shown that high tolerance levels is required for even the most basic forms of cooperation. Unique forms of human cooperation could not have evolved without increases in tolerance. Much like foxes and dogs, our early human ancestors may have been under selection to be more tolerant and less aggressive. And like bonobos, humans may be, in a way, self-domesticated. And as predicted by the human self-domestication hypothesis, later populations of humans show morphological changes in face structures associated with lower testosterone levels. In summary, what's exciting about finding out about dog domestication is that it may have a lot to offer in explaining human self-domestication as well.